Okay, this is Mrs. Kingsbury again. Today we are going to work on what I call target number 5 in this unit. You're going to learn how to solve a system of equations without ever graphing it. So we call this solving systems algebraically. I've listed the steps here that we're going to use. The first part is you remember the definition of substitution. Substitution means you are substituting one value that you know about into one of the equations. So what I have students do is choose the equation that has a variable that's by itself on one side of the equation. So you're going to be looking for an equation that already is set up with either a y equals, or you will see equations with an x equals value. What I like to do in an example, when you have one equation versus the other, find the one that's y equals. That's your nicer equation. You're going to use this to sub into the other equation. I would call this the messier equation because it's got 4x plus 3y on one side, and on the other side it's got this negative 34. So it's just messy. So what I like to do to get students comfortable substituting values, if you look for that y equals or x equals, I usually tell students put a box around the value. We know that y all by itself equals 10 times the value of x. So that's an important clue, and that's going to allow us to do what's called substituting. So if y equals 10 x's, we can take that value and we can substitute it in. I got to go this way, to the y in the opposite equation. And the reason you could do that, remember, this tells us what y equals. If y is equal to 10 times x, we can replace y, didn't mean to make that extra little weird sign there. You can replace the y in this messy equation with that 10x. The problem is you have to remember what's going on between the 3 and the y. 3 is getting multiplied against the value of y. So I'm going to bring down my plus sign, I'm going to bring down my 3, and I'm going to have you create a space using parentheses for that value of y that we're subbing in. So remember, y equals 10x. So now, instead of having a y, we are substituting it. We are plugging in the 10x, which we know is the same value as plain old y. This messy equation, the rest of it stays the same. So we're still going to have our 4x that was originally there. We're still adding 3 times y. This is the value of y. And it's still going to equal negative 34. So that's the very, very important first step. Subbing in using what you found that says y equals or x equals. Now you're only going to be able to solve for x, because if you look at that messy equation that we subbed into, you've got an x term. You're going to clean this up. You're going to get 30 x's. And then you're going to step back and you're going to say, hey, I know what I can do. This term and this term are like terms. So I'm going to be able to combine. And I'm going to be able to solve. But here's the problem. You're actually only halfway done right now. You only know the value of, whoops, let me move my paper up for you. You only know the value of x. This is a system of equations. If we wanted to go back and graph these like we did the last couple weeks, you would find out that this line and this line cross each other, and they cross at what's called a point of intersection. So what we need to do is we need to find the other half of the point. I can start writing my solution. The POI is, but I can only fill in the x value of my POI, my solution. I need to go in and find the y value. So guys, we are going to do another substitution. Let's go back up to the top and review the directions. We found the y equals. We subbed it into the messy equation. We solved, but again, we only have one variable. So now that we know what x is, we're actually going to do the substitution again. So this is where I like to usually take a different color, and I usually like to draw an arrow because we're going to go back up here where I've got more room on the paper, and we're going to do a substitution with what we know about x now. Now that we know x does equal the value negative 1, I want to go back to this easy equation. Remember y equals 10x? All right, we used that originally to plug into the messy equation. I don't want to use the messy equation again if I don't have to. What I want to do is I want to plug in x now that I know it, and I want to figure out what y equals. So I know that y equals 10 times, remember this coefficient and this variable are attached, so they're multiplying together, 10 times the value of negative 1 that we found down here. Well, of course, 10 times negative 1 is negative 10. Now I know the other half of my POI. So remember, your points of intersections get written up with the x coordinate first and then the y coordinate. And then, of course, we have to check. So once again, checking is just like it's been. You write both original equations. You sub in, my y value is -10, my x value is -1. Of course, -10 equals 10 times -1. And this one takes a little more time because we have to make sure we're multiplying 4 times x, and we're multiplying 4 times y. So this is -4, this is -30, and yes, -34 equals -34. All right, so once you are sure that your x and y values work in both equations, you will say this is your solution. And if we wanted to, we could take a minute, get some graph paper out, we could graph this line, we could take this line, we could solve for y equals, we could graph it, and guess what? They're going to cross at this POI. So graphically, it's a nice visual way to make sure you have the right POI. And algebraically, it's nice because you don't have to graph. So some students really like the algebraic solutions. All right, so this one I have for you. And it turns out that what I would call the messy equation, that's on top this time. I've got 3x's, I've got my -4y, and it equals 2. Again, it's kind of messy because I don't have an x equals or a y equals. Remember that last one, the y equals equation was on top, and it was the only equation that had the nice y equals out front. This is my nicer of the two equations. I know that x all by itself equals y plus 5. So I'm going to put a box around my y plus 5. This is what I'm going to be subbing in. And I'm going to look at my messy equation. I know I can take x's value and I could replace x in the other messier equation. So if I was to draw an arrow, hopefully this time you can actually see it, this value is got to be squeezed into that spot right there. So I'm going to come down here. I'm going to say, okay, 3 was attached to x by multiplying. But I have to create space for this value of x that I'm plugging in. My value of x was y plus 5. The messy equation, after having 3 times x, had a minus sign for y, and it was equal to 2. So my messy equation has gotten a little scarier looking because of the substitution I did. But guys, you solved equations like this way back in like October. So if you remember, all your entire equation, sorry, that did not help things. Try it again. It's a little better. All right, so the entire equation has the variable y, which means we can solve for y. This is attached by multiplication like we talked earlier. So you would need to make sure you distribute, bring down, and then you would look to see if you can combine. Can we combine our 3y with our -4y? Why, of course we can. And solve. And make sure you get not just y, but positive y by itself. So it looks like I have a POI, or sorry, I don't have my POI yet. It looks like I have a y value that is 13. But that can't be my final answer, remember, because a point of intersection has not only a y value, but it has a x value in front of it. So let's go ahead and take this and let's sub it in. We used the really messy equation the first time. So for your second substitution, you're going to use the bottom, the nicer equation. We know that x equals whatever that y value is plus 5. So that means if my y value is 13, I'm going to be taking 13 and plugging it in. 13 plus 5 is 18. So I have a POI of 18, 13. All right. I ran out of room, so I decided to put my check up here where I had some space. Remember that both equations get written down originally the way they came to you. Both equations will have the x and the y coordinate. Remember, we came up with a POI of 18, 13. They get plugged in, and then remember, you're evaluating at this point with order of operations. So 54 minus 52, yes, that side works, or that equation works. And then remember the simpler equation, x had to equal y plus 5, and as you can see, it does. So I'm going to get you started on this third example. Remember, step one was to look for an example or one of the equations that has already been solved for y equals, or it may be solved for x equals. That is your clue that you're going to use this value to sub it into this messier equation. So again, to get you started, you're going to say, okay, I know that y equals this mess here, and I know that y in the messier equation is down here attached to this -2. So by rewriting the 6x, by bringing down the minus sign and the 2, my -2 has to be attached to the y value by multiplying. So your best bet, you really need to use parentheses to plug in that value 5x minus 8, and then everything equals -3. So guys, what I'd like you to do, now that you know precisely how to start this one, I want you to remember what happens at this point. We have multiplication going on here. We have the distributive property. This is a -2. Please make sure you are distributing with your -2. Bring down, combine like terms, and I want you to solve and see if you can get your value for x. And then I want you to sub in and see if you can get your value for y. Go ahead and hit pause when you're ready. Click play to check your answer. Okay, if you came up with a decimal or fractional answer, I bet you thought you messed up, but you didn't. So take a look. This gave you the -10x. This gave you the +16. Yes, this combines to give you the -4x. Yes, you have to subtract 16 from both sides, and yes, you have to divide both sides by -4. So I wrote it as a decimal, but if you listed it as a fraction, obviously just check to see that your fraction has the same value as 4.75. This, remember, is half of your solution. 4.75 is simply the value of x. So to get the value of y, remember, we've already worked a lot with this messy equation, so it's time to work with the nicer equation. See how it already says y equals? That means you're only going to have to do work on the right. So y is equal to 5 times the value of x minus 8, multiply, subtract, you got your y value. So, as always, you're going to take your final or original equations and you're going to follow through with your check. Let's see, y is 15.75, 5 times 4.75 minus 8, we kind of just did that. We got 23.75 minus 8, so of course this one checks. And then this one, let's see, 6 times 4.75 minus 2 times 15.75. Feel free to get your calculator out, or I think I sent you guys a link to the Desmos online scientific calculator. It's like desmos.scientific or something, and I think that'll come in real handy if you're doing a lot of this stuff from home and you don't have your calculator. So 6 times 4.75, I think that's 28.5. 2 times 15.75, 31.5. And let's see, 31.5 minus the 28.5 does give us 3. So as you can see, it's a little, oops, sorry, -3. It's a little time consuming to solve algebraically. There are some very important things to look for, like plugging into which and whatnot. I think in my printed notes, I made a note to you guys that, hey, you're plugging this in first, you're solving, and then you're plugging in again. So you're plugging into the messy equation first, then you're plugging into the nicer equation. For the most part, I think you guys will be okay. I'm attaching some practice sheets so you can get the hang of this. And as always, check in with me if you need help, have any questions or concerns. Have a good week.